Hi, hello again. This is Mr. Pablo, and today you are going to learn about probability of single events. Now, what are probability of single events? Now, when you say events, these are situations that will just happen once, okay, like single events. All right. So, for equally likely events, the probability of a particular outcome is equal to the number of ways of obtaining the outcome divided by the total number of outcomes. Okay, this is the formula that we use for probability of single events. Now, it may look like it's a lot of words, but it's actually very easy to use. So, let me just grab my pen. Let me just use a red perhaps today. Alright, let's look at this question. The following fair spinners are spun. So when you see the word fair, okay, that immediately gives us a sign that these are all equally likely events. Now we can look at that again later on and I can explain more about that. What is the probability of landing on the shaded section for each spinner? Now let's look at all the spinners now. And you should have noticed that they're all equally divided. Like this one is divided into 4 equal parts. That one is divided into 8 equal parts. That one is divided into 6 equal parts. This is divided into 3 equal parts. And that is also divided into 4 equal parts, same as the first one. Now, because they are all divided into equal parts, then we say that they are fair spinners, therefore that they are equally likely events. Okay, for this formula to work, everything has to be similar to this. Okay, everything has to have equal outcome of obtaining an outcome or being chosen. Alright, so let's look at this problem. We're focusing here on the shaded sections. Alright, so let's look at the probability of shaded section. I'm just going to put probability of shaded here. And in this one, number of ways obtaining an outcome, how many sections here are shaded? Then we count it as just one. This is the only one that's shaded, so that's 1 out of the total number of outcomes. So you count all the outcomes, 1, 2, 3, 4, and that is the probability that is shaded over here. And then it's already done. Finished. Very easy. Now for part B, okay, the probability that is shaded over here, I'm just going to put S for shaded. I don't want to write that all the time. Okay, and we notice that there's 1 shaded section out of 8 sections over here, which is done. It's easy. It's already simplified, so we do not need to simplify it further. We leave it as a fraction so that it's also easy to see. If you write that as a decimal, then that would be like somehow a very long decimal. Okay, for part C, the probability that is shaded here, that the spinner will land on the shaded part, is 1 out of, if you count all of that, is 6. Okay. Now part D is very similar again. Probability that the spinner will land on the shaded part here is just 1 out of 3. And for the last one, okay, the probability that a spinner which will land on the shaded one is 2 out of 4, because there are 2 shaded parts out of the 4 area or 4 sectors. And then if you try to simplify this, okay, that will be 1/2. Okay, now there are many ways to simplify this. You can think of a number that can be divided, that will divide 2 and 4, okay, which is 2. Okay, sorry, 2, there we go. 2 divided by 2 is 1, 4 divided by 2 is 2. Or remember that you can use the ABC button on your scientific calculator. If you type in 2ABC 4, and then that will give you an answer of 1ABC2, which is the same as 1/2. Okay, so that's one way of answering that question. Now, if we try to look at some other questions like these ones, okay, let me just try and, okay, there we go. It says here that if a fair 6-sided dice is thrown, what is the probability that the score is? Okay, 5, an even number, an odd number, a prime number, a square number, or a number greater than 4. Okay, so let's investigate again if this is an equally likely event. Now remember that this formula will only work if it's equally likely events. So is this a fair dice? Okay, it already says that it's fair 6-sided dice. If you're not familiar with dice, all the faces of the dice will have numbers 1 to 6. Okay, no numbers that will be repeated. So we can say that this is fair. So for question A, if we try to answer that, what is the probability that the outcome is 5? Okay, so if you think about a dice, how many 5s do you see there? Well, you only see 1 5 over there out of how many numbers do you see, which is 6, because there are numbers from 1 to 6. Alright, so that's the final answer. The probability that you will roll a 5 is 1/6. Okay, what about B? Right, what's the probability that you will roll an even number? Okay, so what are the even numbers? So before we answer that, maybe it's good that we write down all the numbers. Okay, I should have started this in the beginning. Right, so probability that is even, which here are even numbers? Well, if you know that 2 is even, 4 is an even number, and 6 is an even number. So how many even numbers do you see? We see 3 even numbers over there out of how many numbers are there? 6. Okay, so we simplify this using your calculator, using the ABC button, then you can write down, you will see that it is 1/2. Okay, again, if you type it in the calculator, that's 3ABC6, and it will give you 1ABC2, which is 1/2. Okay, right. Now, what about question C? Okay, a probability that it is an odd number. Right, odd number. Let's choose that color now. Alright, now which are the odd numbers here? Now, this is an odd number, that's another odd number, and that's another odd number. So to get the probability that you will roll an odd number, sorry about that, is equal to, how many odd numbers are there again? There are 3 odd numbers out of 6, which same with the even number. If you simplify that, that will be 1/2. Okay, now part D. Probability that you will roll out a prime number. Now this is the mathematical term that a lot of students forget. Okay, what is a prime number? What is a prime number? Now, a prime number is a number that has 2 factors, 1 and itself. Now, in a simpler way, you can answer that by saying a prime number is a number that you will never see in any other times table except for 1 and itself. Okay, so that's quite difficult to understand, so you will have to get used to it. So what are the prime numbers here? Now, to tell you that 2 is a prime number, in fact 2 is the only even prime number, the rest will be odd. Okay, but not all odd numbers are prime. Alright, 3 is another prime number, and 5 is another prime number. So the probability that you will roll a prime number is, well, how many prime numbers do you see again? You see 3 prime numbers out of 6. Okay, and again, if you simplify that, that is 1/2. Right, seems like nearly everything is 1/2. That's not always the case. Right, now next, probability that is a square number. Okay, probability that the number is a square number. Okay, so what are square numbers? Square numbers are numbers that, okay, for example, if you multiply a number by itself, the answer there will be a square number. So for example, you've got 1 times 1. Okay, 1 is a square number. 2 times 2, 4 is a square number. 3 times 3, 9 is a square number. Okay, so the answers to when you multiply a number by itself is a square number. So when you go back and look at what are the square numbers there, okay, so you should be able to find out that there are only 2 square numbers in there. Okay, which is 1, that's a square number, and 4, that's a square number. Okay, so there are 2 square numbers out of 6, and if you simplify that, that is 1/3. And the last question over here, question F, a prime number that is greater than 4, a number that is greater than 4. Okay, so how many numbers are greater than 4? That is 5 and 6. So that is 2 numbers out of the 6 numbers, which is 1/3. Alright, that ends the lesson for probability of single events. I hope you learned something from that, and thank you for watching my video.